Hello everyone, welcome back again. So today we are back to streaming again, like clockwork. I just realized that let's see if the desktop camera also works. Great. So yeah, we were, yesterday we were streaming a little bit and fixing one Glasgow. This guy here on the desk. So I wanted to continue on that quest and hopefully finish fixing the other three that are here on my desk. And after I finished the stream, or at the very end, Mike mentioned that I should also update Glasgow the tools. So yeah, let's see. We have 5 viewers, that's good. I think I posted everything to... Yeah. So yeah, so TNT is... we are trying out if having someone also speak on the stream who is in Discord in the voice chat will work. So we have TNT over there who volunteered to scream at me when I'm probing ground pins instead of signal pins. So we will test that out. And he says you had to mute me in Discord. So I think the better solution is actually to mute the stream, on Twitch, and then hear me on Discord, because then what I'm saying makes more sense for you. The video will be delayed, that's true, but it's like, I think it's better that the video is delayed instead of my voice being delayed, because then you can react to whatever I'm saying more. I don't know, it's up to you. So this is an experiment again. I learned a little bit more about Pulse audio channel routing and stuff today, which was really a lot of fun. But yeah, anyways, whenever you want to try out, if you can if people can hear you on the stream, that is something you could do, TNT, if you want.
Okay, I'm trying now.
Okay, I hear you at least. Can you speak again and I can see what the levels are here in OBS?
Yeah, sure. I can speak and say, I don't know, test 1, 2, 3, 1, 4.
So I think I hear you earlier than it is actually showing up on Discord, which is in OBS. But anyways, someone has to confirm from the Twitch stream if they hear you, because it should be streaming out at least. I hope so. All right. Oh, sounds good. Okay, thank you, Josh, and welcome to the stream. All right, so let's get on it. So yesterday we repaired this Glasgow here. We had a rotated level shifter, and we had some shorts on some resistors, as well as shorts under the ESD protection diodes. What we still wanted to test is another self-test that the Glasgow can do itself, is to loop the pins. So we should just try doing that. I got some more jumper cables. So we will have to jumper it from one side to another, as far as I understand. So let me switch over to the... I think it is this one. Let's see if that works. There we go. So I also changed the view where you should now be seeing the whole desktop or the whole terminal, which should be better and not covered by all the different video feeds. So self-test help. And that should list the different test modes. And what we need is pins loop. And this requires pins A0 to A7 must be connected to B7, B0. Is that like crossed over? Oh, because they are across from each other. So I assume they go just from one side to another. So either I can use this. Let's use this. Nice cable from an ancient cellular logic. So these are the signal pins are the closer to the center, right? Yes. So we have some here and then only 2 are left. And 7, okay, just goes across like this. Is that even visible? I have too many screens here. Move this out of the way. There we go. That's much better. There we go. And I also tried out yesterday taking the stream recording and upload it on Diode Zone, and that worked fine. So now there is a video on demand or recording from yesterday's stream archived on Diode Zone. And that's without the music because I was able to record the stream without the music, which is nice for copyright reasons. All right, one more and one more. So let's see if that works. There we go. It's all right. Pins loop. Let's see what happens. I need a faster machine for synthesis, I guess. Fault. So what's the issue here? B1, A6, A7, and B0? Did I just, did I cross over something? Oh yeah, I did. I did cross over things. So that's user error. The error is between keyboard and chair. Let's try it again. Oh, come on. Yeah, this is why I was saying I should make a ribbon instead. But I need to get the connector for that, or the housing for this. Ah, very good. So that worked. That's great. All right, so loop also works. That is true. Oh, so it doesn't rebuild the stream. Oh yeah, okay, yeah. I should probably just make a list. What makes most sense? So where should we start? Let's do help and then list them in order. Because I think they are also executed in order, right? So pins internal, and then pins external, then pins pull, Then pins loop, we have that. Then traces faults in the USB FIFO traces. No requirements. Should loop be first? I think it should. Loop be first. No, loop back. So, Sylvain, you're welcome to just chime in voice. You don't necessarily have to just write it in the chat. You can use the voice if you want to make a comment.
Yeah, it just feels weird to interrupt you. But I don't think you can list pin loop in the same command because you won't have time to just reconnect and disconnect the loop back between the pins internal and the loop.
Oh yeah, you are right. Oh, because they have to be disconnected for the other tests, right? I see. Okay. So I have to do pins loop and then loop back. Loop back was the last one, so that is at the very beginning already. Voltage would be the last one. And voltage can be always connected, even if I do the other tests, right?
As far as I know, yes.
So let's do this. Sorry. Pins external fail short. But I disconnected it. And pins pull B1. Why is it doing that? Now it's making more errors? What the hell? Self-test fail. Fail high. Fail short.
I think the tests are somewhat
yesterday.
not deterministic.
Yeah, it looks weird. It looks like maybe the time. I do remember Whitequark mentioning something about it being, the timings being very short. And I would assume if the something is charged, it might consider it failing. Oh, it's even more now. Wow. That's impressive. Okay. Let's choose just pure self-test then. It was working yesterday at least. Yeah, that works. Oh god, that's weird. But what if I do the tests on their own? Like, for example, the pin external that was failing. Because it was passing yesterday. Yeah, it's passing now. It's only in the combination with the other tests, it seems. And then pins pull, yeah. Let's do pins pull.
Trying on some of my hardware to see
passes on its own too. Yeah, I think now it is, if I run the tests one by one, it is passing without problems. If I run them all together, then it does weird stuff. I still am considering this board to be fine. Okay, I want to look at another board and see if we can fix another one. Yeah, let me know what you find on your board. it might be that we have to run the tests with bigger delay in between or something, because it might be related to that.
It seems to pass reliably on the ref-c that you built for me, but maybe the flux residue have some influence if you haven't cleaned them up.
Ooh, yeah, that's a good idea. Let's clean it up then. Let me just pull this out. Yeah, that's a good idea. Let's do some cleaning. I should refill my IPA bottle is pretty empty. Let's do some. Does this work? Let's see. Don't have a proper preview here. All right. There we go. A little bit IPA. Let's see how much I will spill. Delicious. All right. There we go. Wow, of course. Spilled it all over the table. That's not a big deal though. There we go. And making a mess on the floor. There we go. Even though this should be actually no clean, I think maybe the burned residue of the no clean is still somewhat impacting the signal integrity there. I wouldn't be surprised. Also, my rework might not be 100% perfect. Might be some conductive debris, as people call it, somewhere on the board. All right. Let's see if that helps a little bit. Anything else? I think I mostly was reworking these resistors and level shifters. There we go. Okay, let's try it again. But I need the voltage stuff. Second one. There we go. Let's do the let's loop back pins int ext pole voltage. Hi, Colonel Bob on Twitch chat. Welcome to Twitch. Oh, hello, Death Fudge. Welcome. Oh yeah, now it passes. Yeah. So then you were right. I just needed to clean this up. Perfect. Okay. So now it is doing the thing. Let's do just the loop thing also, while we're still at it. How do I do this the most stupid way? Red. Next one is black. And yellow. I just need what? I just need a ribbon cable with this amount of pins. Yeah, that would be the easiest. Is that the same with how much is it? It's 10 pins, right? Yeah, I need a 10-pin ribbon cable. That would make things easier. Although it doesn't help for the loopbacks. But I could just cut those, loop them back for the voltages. Yeah, that would work. Just have the ribbon cable and cut the last two in the first two and do loopbacks in them. So I could make a wire harness for this. And should do this. There we go, and now just these two. So I hope that my streaming today earlier will allow at least a few people in Europe. I know Sylvain is in Europe, but you're staying up late usually. But others were complaining yesterday. I think Noobwaffle wanted to join the stream yesterday and couldn't because I was streaming too late. Yeah, let's hope today is a little bit earlier and it helps with that. All right, pins loop. Let's do it. Should adjust this. Oh yeah, so loop works too. That's good. There we go. It's my weird tree here. Okay, so let's move on to the next one. So this one is considered fixed and cleaned. Let me put this to the side. This one is also a working one. That's from my previous run. Where should I put this? Here. There we go. All right, let's see. Fails, QFN bridges, dry joints. Okay, so this one will need some QFN rework. Oh yeah, that doesn't look great. Focus, 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 focus. Yeah, these are definitely dry. Dry. So dry. Yeah. It looks like I was trying to rework it, but I didn't do a great job in the time constraint. Okay. So should I get the heater out? I think this is easy enough. Shouldn't require too much. So one thing that I remember or failed to mention yesterday, I'm very grateful to all the people that are still supporting me on Patreon over the last year. Thanks to that, that is essentially what paid for the new cameras that I can use for the streaming. And so thank you very much for staying supportive there. Yeah, most people unsubscribe, obviously, because I was not creating any content, which is totally fair. And yeah, I hope that now that we are getting back to some content creation, some of you might consider supporting me there, because I do want to keep improving the gear here, like getting a dedicated streaming server so that we can easily do some software development on the stream without being afraid that the compilation will break the stream. That's the main concern I have. Okay, so that should work. Okay. There we go. So that should be better. Let's see. Is it still dry? It requires sometimes a few passes to clean up. Burnt plastic. Delicious. There we go. QFN drag soldering. Perfect. This is the main reason I love the tacky flux. This allows you to do things like that. Without the flux, this would totally be not flowing properly, and then I would make more shorts than actually fixing anything. So just a bit more here. There was some debris under the soldering iron. I need more solder here. There we go. There we go. Come on. Very nice. Come on. Okay, let's see. It looks fine. What is going on here? Does it have a fillet? I think it has a fillet. Fillet, fillet, fillet. Fillet, fillet, fillet. Okay, let's clean up the flux and see how it looks after I clean it up. All right. Well, I did mess up the poor fiducial. Not that it really matters. Oh, I pulled off the fiducial. Even better. Great. Fiducial is gone. Bye. Yeah, this is what you get if you solder on a pad that is not retained in any shape or form. The laminate likes to give up and say goodbye to the pad. That's why if you have BGA, for example, and you don't want to lose all the pads that are not connected to a wire, you might want to consider to actually still fan out that pad so that there's something holding it to the solder stop, so it wanders under the solder stop. And that's often a good idea. I hope that makes sense. We also got a contribution to the description of how to describe Glasgow in a short one-sentence thing. I have to look it up again because it was pretty good. It's on Twitter somewhere. I did retweet it with a comment yesterday, but I have to find it. I think it's relevant. Okay. It's starting to look clean-ish. I don't have to do a perfect job, but at least get the most of the gunk out of here. There we go. Very nice. It should be good enough. All right, so first I wanted to get that. How do I do this? Let's do this. Twitter. There we go. So let's see. Yeah, that was from Neil Horman. Let me put this on here. Ooh, that's tiny. So he, no, this is wrong. I clicked on the wrong thing. There, this one. So his description for Glasgow is Glasgow, tool for analyzing, prototyping serial parallel digital I/O interfaces using a dynamically synthesized hardware I/O controller via USB. I think this is a pretty concise description of what Glasgow does. as a tool. That's pretty good. So thank you, Neil, for sharing this. This is definitely useful. We will use that for the description somewhere, so that it is a little bit clear what the Glasgow is used for. So thanks. All right. So now let's test this guy and see if it is actually connecting. Just a basic self-test. Still building, still building. I think it's really the bitstream building should have some feedback to show that it is working. Okay, it is passing at least the basic self-test. Let's see how. Let's do the voltage feedback and then pull-ups. So let's do this. And let's do this. Now we can do the bigger test. Pins voltage, yes, enter. Lib USB transfer. So I bet it is overvolting something, because I think this was the issue yesterday when it was trying to switch on the voltage regulators. It essentially, so pins pull should probably be after the voltage. Pins pull. And then let's do just voltage now.
There's probably a short to ground somewhere so that it resets when you power up the voltage regulators.
Yeah. Yeah, I'm pretty sure that yesterday that was exactly the case. When the short was hitting, the USB was faulting. So I'm sure this will crash again. Or I expect it to crash again. Yeah, lib USB transfer. So yeah, it just does power them on and then resets. So yeah, there is a short. I should get myself, also for the streaming purposes, I should get myself this like a tiny keyboard that has all the scenes available, so I can switch between the scenes easier without every time having to think about what key combination it is. The laptop, yeah. Always something else that can be improved on the streaming setup. All right, so this doesn't look great, but I assume, so let me just measure if there's a short to ground here, because I assume there is. Let's beep it. Am I allowed to measure to ground this time, Silva? Yeah, this is shorted. Okay. Yeah, so it is probably again the stupid how are they called? ESD protection diodes. Oh yeah, and both rails too. So okay, so we need to reflow those. Man, I'm really looking forward to making those fixes to those PCBs to make this easier on me. All right. Still forgot the aluminium foil for today's stream. I hope I will remember for the next time. Okay, let's switch this on. Let's focus. Okay, okie dokie. I have this card. Should I get the aluminium foil, or should I just wing it again with the card? Let's heat this up to 240. Is it warming up? Still warming up. It will take a little bit. Get it to the temperature where I burn my finger on it. Yeah, I wish this cup warmer that I'm using as a preheating pad, the surface on the bottom would be flat, so that would be already an improvement. The second improvement would be to pour some sand in there, so that the contact to the PCB is better. But on the other hand, if I do this, I will get sand debris all over my desk and the board and everywhere, so I'm not sure I like that idea that much. It's nice for spreading the heat, but and conducting to the PCB, but the dirt, I don't know if I like that idea. Okay, is this getting warm? Slowly but surely. Okay, so maybe we should start with the top one, because this is easier to control. Maybe I can give this a crease. It might make things easier. I need to filter those tracks, because I'm not a huge fan of this one. That's better. All right. Let me make a small crease in here. Will that help? Yeah, hopefully. All right, let's see. Wah! Oh, I should add flux, right. Flux it up. All right. Come on. My tweezers there. Come on, come on, come on, come on. There we go. Okay, that's one. Let's rotate it. I should move it down, huh? Should be better. So also need some flux, Don't skimp on the flux. Okie dokie. Oh yeah. Hi Timon, welcome to the stream. Yeah, it's the solder physics are awesome. And you have the right amount of flux and everything is just right. It's very satisfying. I also pressed on it because essentially the solder mask, solder stencil for this is not perfect. Has basically too much solder. But we will get rid of the internal pads anyways on the footprint, so this shouldn't be an issue anymore. And here we go. There we go. Let's see if we have if the shorts are gone or not. Ground. Yeah, it should be. Looks good, I think. Okay, let's try it. Ooh, hot, hot, hot. Hot, 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 hot. Right off the hot plate. All right, let's see if that works. Come on. Still on the wrong. Come on, switch over. There we go. Yeah, this should fail though, because I didn't put the jumpers in. It shouldn't crash at least. Come on. Yeah. It does fail, but it doesn't crash, so that's good. Okay, let me repower it. And the jumpers. Let's do it again. Yeah. Why is it redoing it? Ah, passes, perfect. Okay, so that's fixed. Oh, hi, Nick Horman. Nick, right? Neil, NK Horman? Okay. Hi. Welcome to the stream and welcome to the Discord. So he says, I've used laptop tape as heat shield for protecting plastic connectors during hot air reflow. It somewhat works. Laptop equals Kapton. Yeah, you mean, yeah, Kapton tape. Yeah, Kapton tape does help a little bit, but I feel I should just have aluminum tape. I did use just aluminum foil folded 3 times or something and shove that onto the connector. That helps a lot. So that does shield very well. But if you still heat a lot and hard, then it will still seep through and destroy the connector. But otherwise, yeah, I should probably just at least put the Kapton tape on there. So that might help. So Timon is asking how it managed to gather so much solder under the chip. So if we look at how the footprint is, so let me open that. So this is the footprint. So there are pads underneath the chip. These are ground pads. Let me show you. So there's VIOB, and these VIOs should be going into the diodes, and these are generic ground pads as far as I remember. So if I do this, select the part and then switch over to the schematic, yeah, so there you go. So this is just an array of Schottky diodes, and there's ground connected to the external pads, and everything else is not connected. These are the 17, 16, so 19, 20, 21. Let's see. 19, 20, 21 is this main bus, which is supposed to be connected to ground. And it is connected to ground, but we are not using those pads. And it causes more trouble than it helps in our case. So we will remove these completely from the footprint and only solder the external QFN pads in the next revision. So that will help with this shorting issue. Otherwise, I have to control the amount of solder paste on the footprint very carefully so that there's no possibility of creating a short between these pads here. So yeah, I hope that explains it. Hi, Carlos. Welcome to the stream. Okay, there we go. So that has, you can use Glasgow build self-test. That will create self-test bin in the current directory. Then run pre-build self-test. Ah, okay. So I will then probably create, that would be great for a script, to have a script to run the different tests. Yeah, this is not bad. Let's try that out. So self-test voltage, right? Build. But this binary, is that do I have to create binaries for each type of test that I want to run? Because I can't really run all the tests in one go.
You can create a single self-test binary. So you can use a single self-test.bin binary, and then in the run pre-build, you just say which test you can run, and it can do that without rebuilding.
Okay, so I'm doing this Glasgow build --rev C1 self-test. Let me just go to a different directory though. projects Glasgow. Let's do this in here. Bins. Bins. Okay. Glasgow build ref C1 self test. Building bitstream for applet self test. Good. Next thing after that will be to do the other. Okay, so that, then Glasgow, run pre-build. Doesn't autocomplete. Oh, it's a bummer. I don't remember what the format of what it needs to be so that Z shell, what is it called, omazesh, automatically detects what the parameters are. I have to look into that. It would be very nice to have auto-completion for the parameters. Self-test and then voltage. Let's see. Ah, wow, that's awesome. When I run verbose, yeah, this definitely speeds things up. Pass, perfect. Then do, what is it? Pins pull, I think. It's the next one. And then we can do the loop one. Let's do that. Connect, connect, connect. Don't swap pins, that would be nice. So Sylvain, tell us what are you working on currently, if you want to share. Are you working on something interesting people should know about?
I'm trying to run some Glasgow applet outside of Glasgow.
Okay. So you're trying to figure out how to hack Glasgow to do new and exciting things. Pins loop.
Yeah.
Is that it? Perfect. Okay, let's run them. Oh, I can't run them all. Yeah, go ahead. Oh, this is wrong. Right. Now it is building again. Run pre-build. That's better. Yay! Wonderful. Okay. So we have another one fixed. I should still clean it. So let's do that. Wow. Now we have two, what? Now I have 3 working Glasgows. That's a record. god, this is a mess here. All right. Let's do this, and then some IPA. Zoom out. Very nice. Yeah, so I was thinking, besides like rework like this, which will become quite repetitive after a while, even though I find those challenges quite interesting, especially when we are running into problems that require some thinking and some puzzle solving. What is wrong? I was thinking maybe on the one of the upcoming streams we could work on a fairly silly projects that I want to build for TourCamp this year. So TourCamp is, as you might already know, a camping event in Washington. So in the state of Washington, it's on the Orcas Islands. And it is an outdoor camping thing, like a hacker conference thing. And people build a lot of interesting installations for there. There is a full analog telephone network with cables going to the tents, and then there are blinky stuff. So I wanted to contribute to that this year for the first time. And my idea, after I was thinking something with LED panels at some point, but that would require a lot of, what is it called, manufacturing, aka building a structure and mounting stuff on, which I don't really have the resources or time for. So at CCC, I saw this really amazing game, this linear 1D dungeon, which is, it was used to be called Wobbler. That was the original game, and then people started cloning it on Arduino as their own project. So basically it's just a string of LEDs, and you are 1 pixel on that, and you can move up and down, and then left to right is creating a shield or attacking, and up down, and then there are monsters and obstacles that you have to get through. And the cool thing at the Congress was someone mounted it on a pretty tall pole, so you could see it from far away. And it was intriguing, so I eventually went there and played with it, and it was a lot of fun. So I was thinking it would be really cool to build this using an icebreaker, put the whole code on a RISC-V, and it would encompass a bunch of different domains. So building maybe the SPI APA 102 interface in Migen or Verilog or something, and then mounting it to a RISC-V, and then porting the Arduino software, basically rewriting, because I looked into the code and it's quite messy. Probably I would want to rewrite it, and it doesn't look very complicated, so it wouldn't be too much work. Yeah, Twang, that's it. Yeah, thank you, Timon. Yeah, Twang is the cloned game, and there's a lot of forks on GitHub of this. So I was thinking that would be really cool to, as a project on a icebreaker, and then have something cool to install at TourCamp. So yeah, I don't know what you guys think, but that felt like a nice project to do on stream and do the different steps of it. And it's not super time critical. If it doesn't work out, it doesn't work out. But it's then we have some continuous interesting project to work on here on Twitch on the streams. Besides, from time to time, repairing a few boards, something for production or bringing a project further. So. Oh, and if I want to rewrite it, the question would be, should we do that in CircuitPython? And I don't know, would it fit in CircuitPython on the icebreaker without too much additional memory, or should we just do it in Rust or C? Rust is something I would like to play with, so maybe that would be the solution, because Rust is also a possible target for RISC-V. So yeah, give me your opinions. It's like, let me know what you think, and I might listen to you or I might not. So yeah. All right, what's the next? So this guy, both VREGs. So I bet there's a short again on the VREGs here. So if so, then it is an easy fix again. No, it's not shorted. Interesting. Yeah, if I choose Rust, then it will be quite a learning experience for myself too. So, oh yeah, so it is shorted. Okay, so let's do that. But yeah, on the other hand, doing CircuitPython would have the advantage that I do flex my Python skills that I'm trying to acquire. So that wouldn't be bad either. Both choices are very valid, and I'm having trouble to decide which one makes more sense for me. What we also could do, also on stream, which should be just one continuous stream, I guess, is do the FOMU, so Tim Ansell's and Zob's Sean Cross mini FPGA that fits into the USB port workshop. So go through that, because I went through most of it, and that was a lot of fun. At least partly because my FOMU somehow failed and is not being recognized. But fortunately, I have a few more, so we could do that. Yeah, basically do that, and then do the icebreaker workshop on stream. So go through the exercises and play around with it. That might be interesting to some people, to just see me go through the exercises. I don't know. Also, let me know what you think. There were people asking recently that we should have a Q&A or support channel that is with video. So I think having the workshops on stream so that people can also ask questions, that would be nice. Okay, so hi Unexpected Maker, welcome, and yes, I'm streaming again. Welcome to the stream. I see both chats. You are, I see the Twitch chat, which is embedded, as well as the Discord streaming channel. So you can use either to post in. So the only reason, so it turns out that Twitch has this affiliate program, which allows you to modify the website and whatnot. And to get that, you have to meet certain goals. And some of them are, you have to have so and so many people simultaneously chatting in the chat. And so to a certain degree, I should have probably at the beginning forced people to chat on the Twitch chat so that we can get that stupid milestone for whatever reason sorted, so that we can get the affiliate and get over with it. But yeah, I don't know, maybe you lose it afterwards. So it's not a big deal, I don't really care, but it would be nice to at least write on the bottom under the Twitch stream a few links where things are. And I don't think I can do that until I'm affiliated or something. So yeah. But I couldn't find it yesterday where the options were. Maybe someone knows. Oh, so did this crash? Yeah, this applet for the Discord chat seems to be crashing sometimes. So let me just switch this over. Wow. Yeah, there we go. That's good. There is chat and there's Discord. I can open this up and then restart browser. Let's see if that helps. Yep, there we go. You can try it and it should be fixed again. Thanks, Timon. A lot of chattery chew. Don't spam the chat, but yes, thanks for the thanks for the dedication. Oh, it's great. All right, so let's try to rework those stupid diodes. Okay. Should fix this one. Oh, yeah. Ed, that's not a bad idea to use the 3D printer preheater bed, or the heated bed as a preheater pad. That's not a bad idea. Someone posted it on Twitter the other day that one can use a product. It's basically like a flat pad, heating pad that you can just connect to power, and that is fairly flat so that it is not as tall as this. But what I like about this setup with the cup warmer is that it has the plastic case around it, so I can rest my fingers on it without burning myself. So just a heating element would need some heat-resistant plastic case for it that would keep my fingers from being burned. Oh, yeah, so yeah, we have some questions in the chat. So Unexpected Maker is asking what camera I'm using on my microscope. So this is, it says HDMI Full HD, and it is AI Home, the camera. So it's one of those Chinese cameras. It's not great. I don't like how the color looks crappy and it washes out. I probably will switch over to use my Lumix G7 on the microscope and use the Sony RX100 as my desktop cam. So I think I will swap things around to get better quality. So that's, I think, the plan. Yeah, so yeah, the proper cameras on a microscope, they're very expensive. And as I said, it's like I'm very lucky that Chris Gamble wanted to sell me some used cameras. And for the G7, there are adapters that you can mount on any lens, like any camera that has removable lenses, you can put, instead of a lens, an adapter on it to connect it to the microscope, to the third eye. So that's how it works. So it can't be a point and shoot as far as I know. Do you have a public Spotify playlists? Yes, so there's the playlist that I'm playing is actually, that's a good question. So this is, can I share a link? Share, copy playlist link, and that's the, there we go. I hope that works. So it is the new Retrowave latest records playlist, and I just have it on shuffle. So yeah, I'm glad you like it enough to ask for the playlist. That's nice. So yeah, I think how do I connect my G7 to my microscope? I don't have it connected at the moment, so yeah, I need the adapter. I need to get it. Yeah, so the only reason why it will work for my setup here is that I also have the Sony RX100, which I can use as my desktop cam, and I'm planning to probably mostly use that other camera for my normal video creation, so it shouldn't be a problem. So it's really, your mileage may vary. It really depends on which cameras you have at hand and which ones you have to buy. And as far as I see is the microscope cameras, this wasn't a cheap camera either. It was also like, I don't know, $500 or something ridiculous like this, and it's still so crappy. So yeah, the microscope camera situation is not great at the moment. Oh yeah, I'm glad you like it, Timon. Yeah, the playlist is, I really like the new Retrowave stuff, and this playlist has everything in it. I still want to sit down and take that playlist and filter it out, because there are some songs in there, not very many, but some songs that I'm not a huge fan of. So I should filter through and just only put stuff in my own playlist that I like. But this is quite a process. This list has a huge amount of tracks. What is it? It's like, yeah, 666 songs. So yeah, it's a big playlist. Yeah. You could use heated print, yeah, Yeah, so the cup, yeah, so Ed is still, I now read it, regarding the preheater. Yeah, the cup warmer is a very good starter. It definitely will work. But you see there are areas on this that I already smoldered, because the plastic doesn't survive directly being in the line of rework station fire. So yeah. Yeah, so Timon has also a point. Probably most of the artifacts is actually shittiness of my microscope. And yeah, Amscope is, for my eyes, like, looking into the microscope works great. So that's totally acceptable. For the camera, the path is probably not ideal. So it is something, it could be better, but getting a microscope that has simulfocal capability, so you can look through it as well as film at the same time, I would probably have to find something on the used market that doesn't suck. And it's like, yeah, anyways, donate to my Patreon, then we will improve the gear. Yeah, anyways, so yeah, I want to improve the gear over time, but at the moment we will have to live with what we have. And I still want to try the G7 on the microscope and see if it is still as crappy as that. And then we will know if it is just the optics or maybe the camera still has some impact on it. Yeah. All right, so where were we? We were reworking the other side. Yeah, let's do that. All the distractions. That's good, though. I ask questions in the chat if you have any. That's why we are here. Get some work done and get some talking done. Oh, sorry. Should have moved it down. Yeah. The viewport on the camera is smaller than the optical one. It was just heating it up. There we go. There we go. I'm good. So Unexpected Maker is saying that he's getting sore eyes from the microscope. For board inspection, yeah. So for board inspection, probably an external screen would work. For working on boards, I wouldn't be able to do it without this stereoscopic vision. Well, no, that's not true. I would be able to, but it's an advantage of having stereoscopic vision where you have depth perception. I did try to use only one eye in the previously with my old microscope that couldn't have the camera enabled at the same time as as one of the eyes, so I had to trade one of the eyes for the camera, and not having stereoscopic vision was very annoying. So yeah, that's why I got a different microscope eventually. And let's see. Okay, no short here. No short here. Okay. Let's see if that's fixed. Hot, 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 hot. Let's switch over. There we go. So let's just do just a pure self-test and see what happens. And bam, okay, that's good. Then voltage. Self-test, self-test, voltage. That should fail. It fails, but doesn't. Yeah, I keep forgetting to add this. So yeah, there is a plan to have a tester, a pogo pin tester for Glasgow's. We really have to get going on this from the mechanical standpoint. I have to send an order for them. Pass, perfect. So that's good. Then self-test pins pull. Ed is asking if I'm using a Barlow lens. Yes, I am. I have a Barlow lens on the on this microscope because otherwise the distance, the working distance, is very short. As well as like I just need 10x essentially. So I think at the moment it is 0.7. Yeah. So this is 1x and then 0.7. So yeah, I usually do have the 0.5 Barlow lens on here. The lens that comes before the microscope is probably also a fair factor. So is there a lens in here? I think there is, because that's the adapter on this. Yeah, I don't know. I'm really curious what adapter I need for the G7. I still have to look into this. If it is actually a lens, because sometimes it is a lens that I can mount on this, what is it called? I don't even remember, like micro something, the mounter on there. But yeah, okay, so it is failing short in the pull-ups. Let's see if this is actually an issue or... It's probably related to the dirt. Is it consistent or inconsistent? Yeah, it's inconsistent, so it is just dirt. So let's clean it. Yeah, I have the 0.5, not the 0.7. 0.7 probably would work too. Yeah, the main reason is the working distance. That's why I have one. Okay, let's clean. Mm-hmm. They are crooked. I don't like that. I will have to live with it, because usually it's not really worth the hassle. All right, so let's see if it's better. Duh. Okay, still more cleaning, huh? Okay. Get a clean Q-tip. On the A side. I should also clean around the FX2. So, Walrus, welcome to the chat. I think you. So, yes. So this is actually no clean, which doesn't have. So it's designed specifically so that you don't have to clean it off. What does this mean? It is exactly related to the conductivity. It is. Rosin flux is very conductive. You have to clean stuff after you use it. I learned it the hard way by ruining a board that like one of my first boards I ruined that way because I didn't clean off the rosin flux, and then got a short and like destroyed the microcontroller and stuff like that. So that wasn't fun. That's the water soluble flux. It's only so that you can use water as a solvent, but you have to clean it almost immediately because how corrosive it is. So that's also not a great choice. And no clean, in general, is not conductive, so you can leave it on there. But in situations like this, where the test is pretty sensitive, it still causes issues. Yes, so yeah, I think you might be right that if it is not fully baked, it is not in the no clean state. So Sylvain it makes a good point. Definitely, if you have no clean in solder paste, you reflow the board. You don't have to clean the board because it won't be conductive. It might still have impact on RF and sensitive circuitry. Possibly, I don't know that. It's just I imagine that. Second of all, if I'm using the goopy no clean flux for rework, I did see that it has very residual connectivity, and it's either the overheated burnt side products are the problem, or the flux that wasn't heated enough yet to convert to the no clean format. So it's possible that either can be a problem, and I don't know which one. But yeah, that is definitely a good idea to clean it off after. If you did some rework, I try to do that on my boards. But I do like using no clean because of my previous experiences with rosin. Okay, so let's try it again. See how bad it is. Yeah. Oh, come on. That's annoying now. Keeps being an issue. Do I have to pull out the brush? Let's do one more round of the Q-tip. angle grinder. Yeah. And just take the angle grinder to this. No, you should. We should take this rough metal brush on a drill and just clean off the PCB with it. That's how it works. That's the best way of cleaning. let's spread that rumor that this is the best way of cleaning PCBs. It's like telling people how to teach me how to hack. Yeah, type rmrf/. Or do something to 127.0.0.1 IP address. Yeah. Horrible, horrible. Mean people. But we are not mean here. We try to be nice to each other. Yeah, I think I need a little bit more. There we go. Let's see if that helped. I might have also like dry joints here. That's a possibility. Yeah, that looks good. It does look fine. Okay, well. One more try. Back and forth, back and forth. Oh, it's even worse now? You're kidding me. Oh my God. Oh, so bad. Let me get a brush. Where's the brush? Where's the brush? There we go. Anti-static brush to the rescue. Okay, so Greg DeVille. Oh yeah, Greg. Is Greg taking well, he likes to delayer PCBs, so this is where he is taking sandpaper to it, which is very nice. Are there other pins just floating? That is possible. I don't know. These pull-ups are pretty strong. Actually, I think they're, what, 100K? No, it has to be less. Resistors. Yeah, and regarding EE versus software guy, so yeah, I shouldn't be doing any of this either. I'm also a CS. I'm just pretending like I know anything. So yeah, dangerous half knowledge. That's the ticket. 10K, okay, yes, so there are 10Ks. So it is quite a strong pull. Let's see if that works. Come on, do it. Oh, screw you. Yeah, the cleaning I will do some other time. This is stupid. This is not really interesting for the stream. Yeah. It just fluctuates between working and not working and working and not working. Yeah, this is dumb. It just trickles through. Yeah, I probably should put it in my ultrasonic cleaner and clean it properly. That's what I will do. Anyways, so that one has to wait for later. Let me mark it as problematic. Where's my scissors? My scissors. And let me mark this guy with some blue tape. There we go. That should make it clear that it needs some more love. Okay, last one. You have 20 minutes. Do you think we can fix the last Glasgow in 20 minutes? Let's try to do that. Yeah, there we go. Let's see, what was the issue with it? Both VIOs fail to come up, pulling 300. Yeah, so it's another one with the. So they basically all had the voltage issue, it seems. So the most interesting one seems to have been the one from yesterday. That had a bunch of different issues. This now we are just dealing with some stupid shorts. Yeah. We need a stupid short emoji. Yep. Come on. Yep. Okay, so we have shorts on those. So yeah, so walls rowers, that's exactly what it is. It is a high resistance path between the pads, somewhere like on the level shifters or on the resistors or somewhere there, and this is causing the issue. And yeah, the 10k ohm pull, it's essentially if you have a floating pin, it will still be able to pull through the high resistance next to it. So yeah, I don't exactly know what the yeah, so output enable output input. So the input is reading. So I don't exactly know what the algorithm here is. If it is pulling one pin and then checking the all the others, I think that's what it is. And then if they are just high Z floating those pins, then even the slightest pull will cause issues. So, but I think they are also pulled down on the other pins. So I would assume that the problem is that it's still leaking through. Yeah, wait a second. So this is output enable output. So output is, so basically you are taking a pin and driving it high versus other pins are just inputs. And then you check what the input is. I think that's how it works. And then if you have a high impedance path, you still will pull those inputs high or low next to it. So you don't want them to have any shorts. Yeah, they have defined states. Especially if you have pullouts and pull-downs, so they are defined by the pull-downs. But I would have to look into the applet. I don't exactly remember what or know what Whitequark did in there. So why am I unloading this? That's stupid. Okay, so let's go here. There we go. Let's heat it up and then not flux. There we go. Yeah, Walrus, I don't actually know. I would have to look into the code, which pulldowns are enabled or not, how the test is actually written. We can look into that after I'm done with the rework, because this is actually interesting, yeah. Okay. Let's test this. Okay, seems to be good. Let's do the other side. What am I losing here? There we go. Well, thanks, Walrus. So regarding the Twitch affiliate and the panels, I saw that you can add like add-ins into the bottom, like under the video, but I couldn't find a way of adding arbitrary text or pictures, what I saw on other channels, but I might be looking at the wrong thing. Maybe one of those panels that you can, because they say it's like, please add a plugin for Spotify, add a plugin for some other app or YouTube or whatever. But I have not seen just here, add some text and a header. There's a big box with a plus. Oh, that thing? Okay, so maybe that's how I'm adding it. Okay, I will look into this. So that's good. So I can add some description there. Thank you for looking it up. Yeah, that's good. Thank you, Walrus. So the only other main reason to become affiliate now is to become part of a team, and I would like to join the live coding team that Ninja Bunny is part of too. If you don't know her, you should check out her Twitch channel. She does really awesome stuff. I think Shalen 50k is also, or 5k, or one of the other assembly C64 live coders is also part of that team, which is also nice. So yeah. but it's not really a big deal. So just things. More important is that. Oh, you're a sub of Ninja Bunny. Great, yeah, she's awesome. I met her a few times in Rio now. Very nice person. Okay. Yeah, there we go. Okay, hot, 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 hot. Let's see what it does. Pass, very good. Now let's do voltage. Voltage test. One, two. Pass, very good. You should have it in verbose. Now the pull-ups will probably fail. What do we want to bet? Pins pull. Yeah, something is failing. I have to clean this. Let's do the loop. Oh yeah, thank you for the link, Wallers. Also, if you're interested in really cool streamers, you should look up Shallen50k as well as, let me see, they create games in assembly for 6502 microprocessors as well as NES, and it's pretty cool to watch. Let's see. Come on. Oh God. There's the list. The other person is Zorkenheimer. Yeah. Yeah, I will give you a link to this too. These are really good channels. Let's get the link. It's a little bit slow because I have so much open in here. And Twitch is a heavy website. Oh yeah, Bold Engineer. Yeah, there you go. Yeah, you should put in your link in there too. I really enjoy your streams. So that's electronic related. That's definitely, you guys should follow Bold Engineer. And here's an unexpected maker. No, your stuff is not worth following. No, I'm just kidding. No, unexpected maker makes also awesome stuff. You should definitely follow him too. So yeah, there's a good group of people. So yeah, we should create a list of interesting channels. I will add that underneath my Twitch channel to make a list of people that are worth following. It's a good list. It's like we are putting something together. And there should be always more. Always more people doing electronic stuff on stream as well as on YouTube. It's like there's a dire need of those. I think there's still not enough people. Also, like doing all the different things. It's like on lower and higher level, rework, soldering, creating, designing. From Arduino to Verilog and digital design, I think there's a full spectrum that can be covered. All right, and let's do the loop. There we go. Okay, let's do pins loop. See if that at least works. Yeah, what did I do? Did I rotate something? Brown. And blue. Pins loop fail. B6. B6. A1, A0, B7. Yeah, there's some shorts here. So yeah, I guess I have to clean this up. Yeah, anyway, so this is pretty much it. Let me do a cleanup. If that works, it works. If it doesn't, I will clean it up later. But we are getting close to having something more working Glasgow. So that's very nice. We should still figure out what we will do on the next stream. One thing that I got that we could play with, where do I have it? Did I put it away somewhere? So I got this, there we go. No. Where the hell did I put this? I'm blind, it seems. So people found out that the LED panel driver boards, they in the newest generation. There I found it. Is that the desk? So this guy. So this is a board that you use to connect your computer or a driver board from your PC to LED panels. LED panels is in this guy. Something like this. And it turns out the newer generation of these have an ECP5 FPGA on there. So if you pull this off, there's a Lattice ECP5 in there. And yeah, that's a supported FPGA in the open source toolchain set. So several people were getting those and reverse engineering the circuitry. And I know Mike already uploaded a bit stream to this. There are two different kinds. There's the E version and there's like a B version. So if you decide to get one of those to do FPGA development, you should get the, or then you can get any of them. But if you want to drive LED panels, especially those 64 by 64 resolution ones, you should get the E version, because E means that it has an additional address line, so you can drive those 32 line scan LED panels with them. So if you want to play with LED panels, this is what I personally actually got it for. I want to have an maybe open source supported LED panel driver board or something, or just use it as is. It's like I started playing with the software, with the vendor software, but it is only for Windows, and I still don't know how to stream videos where I use Windows somehow. So I don't know, I have to figure it out with like a remote desktop to my main machine, because I don't want to virtualize it on the streaming machine. Yeah, anyways, so this is an interesting thing to play with, but we could at least try to extract the bitstream out of the current one, and maybe upload something blinky ourselves to it. So that would be fun. Yeah, so the non-E version of the receiver boards has only 8 channels instead of 16 channels. So there's less of this connectors on there. This one will have more GPIO broken out to the connectors, because each one of those needs its own data. So there's 6 data pins on each of the connectors. So you have definitely way more GPIO available on those connectors. I'm pretty sure the level shifters are fixed to be only output. So you would need to do small rework of like lifting a pin and changing from ground to VCC or vice versa to switch it over into an output. But yeah, there's probably some work to do, some reverse engineering on these. That would be fun. But there's also other projects that we can work on. There's PCB design stuff, like working on the next generation logic analyzer for SIGROC that has more bandwidth and more pins, and. So ideas, I have plenty. I should probably make a list of those different ideas for different things we could work on the stream, and then see what people are interested in working on. Yeah. So Walrus is asking what time zone I'm in. I'm in the Pacific time zone in the US. So Pacific Standard Time, PST at the moment. I'm always mixing up the PDT, PST thing, because it's like summertime, non-summertime, whatever. But I think it's PDT at the moment. Yeah, -8 PST. Yeah, that's correct. Thank you, Thank you, Bob. Oh yeah, I always ask Google too. Yeah, it's annoying. But I'm not doing it now. Let's do some cleanup here. There we go. Let's see if that helps. Probably won't fix it fully, but at least it's a start. Yeah, I probably just should... wait a second, what's going on here? It's a very small amount of solder on this pad here. Oh, I should change to this view. Yeah. There's several other things that I need to also fix on my streams. It's a lot of streamers have alerts when people subscribe to the channel. I don't see them. I only afterwards realize. So I think I've seen several people subscribe to the channel, and while I was streaming. So thank you all the people that did that. I'm sorry you didn't get a shout out. I will try to do better in the future. Welcome to the stream. Welcome to the channel. I hope you enjoy the things we are doing here. There's more to come, and hopefully a schedule so that we will be streaming on a more regular basis. So far, I'm having a lot of fun doing this, so let's try to keep it up and keep doing it on a regular basis. I have to figure out which days are like regularly would work for me, so that it doesn't conflict with some other appointments. But I will try to stream at least, I don't know, 3 to 4 times a week, so that there is some regularity. This way the streaming setup will not get completely dismantled, which happens every time I don't stream for long enough. What did I say? If I don't stream for long enough, then the streaming setup gets dismantled. Yeah, exactly. So I want to keep it set up so it doesn't take so long to get it back set up. After it took me almost a week to bring things back into normal mode, so that I was ready for streaming. But yeah. So let's see. Let's do not loop, let's do pull and see if that works. Oh, that passed. That's good. That's nice. So let's try the loop and see if the cleaning was good enough. There we go. And 2 more pins. What happened here? There we go. There, and there, and there. Okay, let's see. Let's do the loop. Ba-bam! Okay, wonderful. So we have now 5 working Glasgows, except one that is a little bit wonky, needs more cleaning. So yeah, that's awesome. So that's a big improvement. I'm happy that it didn't take us, that we managed to fix more boards on this stream. As I said yesterday, after we figure out what the common problems are, it will be much faster to fix the rest. And yeah, I think I think I know what we should work on next time. I think we should do the design changes on the Glasgow that we want to do. The footprint changes, as well as I wanted to redraw Hannah so that she looks good on a whiteboard. Because if you let me switch over to here. So yeah, is that visible here? Yeah. So this is not great. We should I need to change Hannah so that her face is the same color as the background, I think, and just make it outlines. That will be an improvement. So some exercise in drawing skills, I guess. But yeah, I don't know. Maybe we will do it on stream. Maybe I will do it on my own. But definitely we need to make the changes of the footprint for the diodes, as well as the SOT666 footprints need to be replaced. And we can do that, I think, on stream. That would be fun. Then we have also an opportunity to do some exploration on the board and look into the different circuits that are on here. And yeah, so that would be a fun project, I think. And then we can also look into driving the APA 102s for the I already forgot what was the name for the Twang projects. Yeah, there you go. To get the 1D dungeon crawler working. But yeah, I will make a more firmer decision before the next stream, and I will let you guys know. So before we part, let me see. Is that? Let's see. Yeah, there we go. So before we part, I would like to say a few things. First, thank you very much all the Patreons that are supporting this channel. Even though I was not streaming, your donations definitely were used towards the streaming capability. It's like otherwise I wouldn't be able to afford those extra cameras, which was very useful. Check out that. It's in the links down there if you are so inclined and want to and have some spare change. But it's like the most important thing is that you guys are here and you're enjoying the streams. I hope you're doing some hardware hacking yourself, or this will inspire you to do so yourself. We have a Discord server, so join the Discord. And between the streams, we are definitely discussing a lot of interesting stuff. There is a lot of open source FPGA stuff. There is some microcontroller stuff. There's a lot of different discussions about interesting technical topics, and as well as some just general chit chat. So join the Discord. Yeah, subscribe to the Twitch channel. I will definitely be streaming more. I still don't have a fixed schedule. I will be announcing it on Twitter, on Mastodon, as well as on in Discord. I will be sending out alerts as soon as we are streaming again. I'm not sure when I will come back, but maybe tomorrow, maybe the day after, depending. Tomorrow is a holiday, so it's not a bad day to do some streaming. Anyways, if you are still here, if you have any questions, say them now. Otherwise, I thank you very much that you joined. I hope you had fun, and proszę bardzo, nie ma za co. And if you have been, thank you for watching. So, bye.